Welcome to the DIY Honda Garage channel. The diagnostic trouble codes DTC P0721, P0722, and P0723 relate to the countershaft speed sensor of the Honda Accord models ranging from 2017 to 2023. A malfunction in this sensor can significantly impact the vehicle's automatic transmission performance by failing to provide accurate speed data to the Transmission Control Module, TCM. The countershaft speed sensor is located within the transmission assembly, playing a critical role in monitoring the speed of the countershaft. When the transmission operates, this component generates electrical signals that inform the TCM about the current speed, which is vital for shifting decisions. Each of these DTCs represents a different aspect of countershaft speed sensor problems. P0721 indicates performance issues, P0722 indicates a no signal received, and P0723 suggests an intermittent signal. Addressing these error codes effectively is essential for restoring proper vehicle function and ensuring a smooth driving experience. The countershaft speed sensor is responsible for providing the TCM with real-time data about the rotational speed of the countershaft, which directly influences the transmission's ability to shift gears smoothly and efficiently. Located within the transmission, this sensor utilizes magnetic or Hall effect principles to generate a voltage signal proportional to the rotational speed. The accurate operation of this sensor is crucial. If it fails, it can trigger one of the three DTCs mentioned. A countershaft speed sensor working correctly enables the TCM to adjust gear ratios as necessary, promoting overall vehicle efficiency. With the advent of modern automatic transmissions reliant on electronic control systems, a malfunctioning sensor can lead to erratic shifting, decreased fuel efficiency, or even full transmission failure. Consequently, understanding the role and location of this sensor helps in pinpointing the diagnostic issues and repair pathways. Several factors can contribute to the appearance of DTC P0721, P0722, and P0723. A primary cause is a faulty countershaft speed sensor itself, which may have worn out over time or suffered damage from external debris or heat. Additionally, wiring issues such as frayed wires or corroded connectors can interfere with the sensor's ability to transmit a clear signal to the TCM, leading to erroneous readings. Another possible cause is a malfunction within the TCM, which may misinterpret signals due to internal electronic failures or software bugs. Other related causes can include poor grounding or electrical shorts within the wiring harness. Identifying these potential issues accurately is vital for effective troubleshooting, allowing technicians to address the root cause and restore normal operation. The symptoms associated with DTC P0721, P0722, and P0723 can significantly affect the vehicle's performance. The driver may experience erratic gear shifts, where the transmission unexpectedly changes gears, leading to an uncomfortable driving experience. Poor acceleration may also be evident due to the transmission's inability to select the optimal gear for performance. Juxtaposed with these symptoms, warning lights on the dashboard may illuminate, indicating that the vehicle requires immediate attention. Understanding these symptoms is crucial for drivers to recognize potential transmission problems early. Ignoring these signs can result in further complications or damage to the transmission system, emphasizing the importance of addressing these DTCs promptly. An informed driver can seek timely repairs, ensuring their vehicle remains safe and efficient. The first step in troubleshooting DTCs P0721, P0722, and P073 is to verify the problem through careful observation and testing. To start, raise the vehicle securely on a lift, making sure it is stabilized to allow all four wheels to rotate freely. Once positioned, turn the vehicle to the on mode without starting the engine. Clear any existing DTCs using the Honda Diagnostic System HDS interface. Start the engine and disable the Vehicle Stability Assist VSA feature to ensure it does not interfere with sensor readings. Run the vehicle at speeds exceeding 13 miles per hour, 21 kilometers per hour, and compare the outputs for both the output shaft and input shaft speeds on the HDS. If their speeds are comparable, this suggests an intermittent failure, and you should check for poor connections or loose terminals. If the speeds do not match, this indicates the presence of a failure, prompting further troubleshooting steps. For troubleshooting step 2, begin by turning the vehicle off and setting it to lock mode. Subsequently, disconnect the Countershaft Speed Sensor's 3P connector to isolate it from the system. With the sensor disconnected, turn the vehicle back to the on mode. This will allow you to measure the voltage. Using a multimeter, measure the voltage between test point 1, female terminal number 3 of the Countershaft Speed Sensor connector, and test point 2, body ground. A reading of approximately 5 volts is expected at this stage, indicating that the signal is correctly being supplied to the sensor. If this voltage falls short, it necessitates further investigation into potential wiring problems or failures within the circuit. Should the voltage measurement be satisfactory, you can proceed to the next step in the troubleshooting process. In troubleshooting step 3, you will once again measure the voltage, crucial for ensuring the integrity of the VCC3 wire. Starting with the vehicle in on mode and maintaining the Countershaft Speed Sensor's 3P connector disconnected, measure the voltage between test point 1, female terminal number 1 of the Countershaft Speed Sensor connector, and test point 2, body ground. A reading of about 5 volts here indicates that the VCC3 wiring is functioning correctly. If confirmed, you can advance to the next troubleshooting step. Conversely, if the voltage is inadequate, it signals an open circuit within the VCC3 wire that requires repair before continuing further diagnostics. This step is designed to provide clarity on the power supply line that feeds the Countershaft Speed Sensor, ensuring it receives the correct voltage for optimal performance. Following the voltage checks, troubleshooting step 4 focuses on ensuring that the SG3 wire is intact. Begin by switching off the vehicle and disconnect both the Countershaft Speed Sensor's 3P connector and the TCM connector A 23P. With the vehicle in off mode, check for continuity between test point 1, female terminal number 2 of the Countershaft Speed Sensor connector, and test point 2, TCM connector A pin 16. If continuity is confirmed, it indicates that the SG3 wire is functioning properly, prompting the next step, which involves replacing the Countershaft Speed Sensor itself due to its failure to transmit the necessary signals. However, if continuity is lacking, it indicates an open circuit along the SG3 wire that needs addressing prior to any component replacement or further investigation. Troubleshooting step 5 requires checking for continuity to identify if there's any short in the NC wire. Start this process by ensuring the vehicle is in off mode, disconnecting the TCM connector A 23P as well as the Countershaft Speed Sensor's 3P connector. With both disconnected, check for continuity between test point 1, female terminal number 3 of the Countershaft Speed Sensor connector, and test point 2, body ground. If continuity is confirmed, it raises the possibility of a short to ground existing within the NC wire. If that is the case, repairs will be necessary to rectify any short circuits found before you can proceed to the next step. If there is no continuity and everything else is functioning correctly, it allows you to move forward in the troubleshooting process confirming wiring integrity before proceeding further. The final troubleshooting step involves ensuring the NC line's functionality, which is crucial for the system's overall operation. To perform this check, verify continuity again between test point 1, female terminal number 3 of the Countershaft Speed Sensor connector, and test point 2, TCM connector A pin 2. This check should be done while keeping the vehicle in off mode and both connectors disconnected. If continuity is established, it reassures that the NC wire is operating correctly. If everything checks out, it is prudent to reference any authorized service information regarding DTCs or symptoms encountered during the process. Additionally, it may be beneficial to substitute a known good TCM to verify if it resolves the issue. If the DTC clears after substitution, replacing the original TCM may be necessary. Conversely, if continuity fails, an open circuit along the NC wire must be addressed to ensure proper signal transmission. After executing the necessary repairs regarding DTC P0721, it's essential to perform a final verification to confirm the success of those repairs. Start by rechecking the entire system to ensure that the countershaft speed sensor and associated wiring are functioning properly. Clear any previously stored DTCs using the HDS and then perform a test drive to observe the vehicle's behavior post-repair. Significant focus should be placed on verifying that the transmission shifts seamlessly and there are no warning lights illuminated on the dashboard. This step is critical as it not only checks the repairs, but also ensures the longevity of the parts replaced or repaired. Documenting results at this stage helps in identifying recurring issues or patterns, establishing a baseline for future diagnostics if problems arise again. Ensuring proper operational status is the goal, confirming that the vehicle performs optimally with no glitches. To prevent future occurrences of DTC P0721, P0722, or P0723, regular maintenance and inspections should be prioritized. This includes routinely checking the countershaft speed sensor for any visible signs of wear, damage, or corrosion. Ensuring that the wiring harness is free from fraying or degradation, particularly in high heat areas, helps maintain signal integrity. Additionally, routinely updating the TCM software can assist in preventing abnormal function, especially as newer updates may address known issues. It's also advisable to perform transmission fluid changes as recommended by Honda, as dirty fluid can lead to sensor malfunctions and transmission wear. Keeping accurate maintenance records aids in timely assessments and further establishes a proactive maintenance routine that can forestall more significant issues in the future. In summary, understanding the implications of DTC P0721, P0722, and P0723 is vital for maintaining the performance of the Honda Accord from 2017 to 2023. The countershaft speed sensor plays a crucial role in enabling smooth shifting within the transmission, and recognizing its function can help identify potential issues early. Following systematic troubleshooting steps, from verifying the problem to testing continuity and voltage, can effectively pinpoint the root cause, leading to proper repairs. Moreover, regular preventive maintenance and inspections are essential in prolonging the life of the sensor and associated wiring, promoting overall vehicle health. Awareness of how these components interact reinforces the need for diligence in vehicle care, ultimately enhancing driving safety and performance. Please like and subscribe to the channel. See you next time.